April 19th, 1944. Rechlin-Lärz airfield, Mecklenburg, Germany. The captured North American P-51D Mustang sat in the morning light, its natural metal finish gleaming against the drab camouflage of surrounding Luftwaffe aircraft. Hauptmann Werner Stössel, a veteran test pilot with over 200 combat missions, walked slowly around the American fighter for the third time that morning. He'd flown captured enemy aircraft before Spitfires, Thunderbolts, even a Yak-9 brought back from the Eastern Front. But this particular Mustang represented something different, something that had fundamentally altered the air war over Germany in just 6 weeks. The aircraft had belly-landed in a field near Magdeburg on April 14th after its pilot, Lieutenant James McKinley of the 352nd Fighter Squadron, misjudged his fuel reserves during the return leg from a bomber escort mission to Schweinfurt. McKinley had walked away from the crash and was now in a POW camp, but his aircraft serial number 43-24683 had been recovered nearly intact. The propeller was damaged beyond repair, and the belly showed scraping from the forced landing, but the airframe remained structurally sound. More importantly for Luftwaffe intelligence, the Mustang's fuel system was completely intact, and 2 empty drop tanks lay in the field where the pilot had jettisoned them before landing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Stössel's orders were explicit. Luftwaffe Reich headquarters wanted a comprehensive evaluation of the P-51D's range capabilities, not estimated range based on fuel capacity calculations, actual demonstrated range under combat conditions. The American fighter escorts had been appearing over Berlin with disturbing regularity since early March, but official assessments still struggled to reconcile observed operational radius with known fighter aircraft limitations. The distance from English air bases to Berlin measured approximately 560 miles one way. Standard fighter doctrine held that combat radius, the distance a fighter could travel, engage in combat, and return home rarely exceeded 1/3 of its maximum range due to fuel consumption during takeoff, combat operations, and landing reserves. By those calculations, a fighter would need a maximum range exceeding 3,300 miles to escort bombers to Berlin and back. No single-engine fighter in existence possessed such capability. Yet American Mustangs were doing exactly that, and they weren't simply reaching Berlin at the limits of their fuel. They were arriving with enough reserves to engage Luftwaffe interceptors in sustained combat, sometimes for 15 or 20 minutes, then flying home. German fighter controllers had documented cases of P-51 seconds chasing Messerschmitt Bf-1, 109s for over 30 miles after breaking off attacks on bomber formations. This should have been impossible. The Technical Intelligence Service at Rechlin had been analyzing captured P-51 variants since late 1943, when the first B-model Mustangs began appearing in significant numbers over Western Europe. Those early evaluations had focused primarily on the aircraft's high-altitude performance, which proved superior to both the Bf-109G and the Focke-Wulf FW-190A in speed and maneuverability above 20,000 feet. The Packard-built Merlin V1650 engine, producing 1,490 horsepower at war emergency power, gave the Mustang extraordinary performance characteristics that German analysts had documented thoroughly. But the range question remained unresolved. The P-51B carried 184 gallons in wing tanks and 85 gallons in a fuselage tank directly behind the cockpit, for a total internal capacity of 269 gallons. At cruise power settings, consuming approximately 70 gallons per hour, this provided roughly 3.8 hours of flight time. At the Mustang's cruising speed of approximately 300 miles per hour, maximum range calculated to approximately 1,140 miles. This was sufficient to reach Berlin from English bases with almost no reserves, certainly not enough for combat operations, and the mandatory fuel buffer for landing. The captured drop tanks provided the answer, but raised even more disturbing questions. The tanks were cylindrical, measuring approximately 108 inches in length with a diameter of roughly 22 inches at their widest point. Each tank held 108 United States gallons. Two such tanks would provide 216 additional gallons, extending the P-51's total fuel capacity to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.9 hours at cruise power, yielding a maximum range exceeding 2,000 miles. The mathematics finally made sense. What didn't make sense, what had captured the immediate attention of every German intelligence officer who examined them, was the tank's construction. They weren't made of aluminum. The surface felt wrong, textured in a way that no metal could replicate. When technicians carefully scraped away a section of the silver paint coating near one tank's tail cone, they found layers of heavy paper compressed and laminated together with a resinous adhesive. The drop tanks that had extended American fighter range deep into Germany, that had rendered the Reich's industrial heartland vulnerable to daylight bombing, were made from glued paper and wood-based resins. Oberst Edgar Peterson, who commanded the Luftwaffe's captured aircraft testing unit, had seen the preliminary materials analysis and understood its implications immediately. The Americans weren't using paper because they lacked aluminum. The United States produced over 1 million tons of aluminum annually, roughly 4 times Germany's peak production. They were using paper because it was cheaper, faster to manufacture, and freed critical metals for other uses. This was optimization driven by abundance, not scarcity driven by shortage. But Peterson needed more than materials analysis. He needed operational data. Luftwaffe Reich was losing pilots at unsustainable rates trying to intercept bomber formations that now had fighter escort throughout their entire mission profile. In June of 1943, before long-range escorts became routine, the 8th Air Force had lost over 100 bombers during a single week of missions losses, so catastrophic they'd temporarily suspended deep penetration raids. By April of 1944, with P-51 escort standard, bomber loss rates had dropped to approximately 3% per mission, while Luftwaffe fighter losses had climbed to over 30% monthly attrition in some units. The tactical situation had inverted completely. German fighters that once attacked bomber formations with near impunity now had to fight through screens of P-51 seconds before reaching their targets. And the Mustangs, despite official assessments describing them as long-range escort fighters optimized for endurance rather than combat, were proving devastatingly effective in air-to-air combat. Experienced Luftwaffe pilots reported that P-51 seconds at altitude could outrun, outclimb, and outturn both the Bf-109 and the FW-190 above 25,000 feet. This wasn't supposed to be possible for an aircraft carrying enough fuel to fly from England to Berlin and back. Stössel's evaluation would attempt to answer several critical questions. First, what was the P-51D's actual operational radius with drop tanks under realistic combat conditions? Second, how did the aircraft's performance change throughout a long-range mission as fuel burned off and weight decreased? Third, what were the handling characteristics with full drop tanks versus without them? And finally, could German pilots exploit any tactical weaknesses revealed during extended range operations? The repairs to make the captured Mustang airworthy took 2 weeks. Luftwaffe mechanics fabricated a new propeller using a blade assembly salvaged from another crashed P-51. They repaired the damaged belly skin, replaced hydraulic lines abraded during the forced landing, and thoroughly inspected the engine for any damage from ingested debris. The Packard Merlin ran smoothly during ground tests, producing full power with no unusual vibrations or oil consumption issues. By late April, the aircraft was declared flight-ready. Stössel spent hours in the cockpit before his first flight, familiarizing himself with the instrument layout and control positions. The P-51D's bubble canopy provided visibility that made every German fighter seem claustrophobic by comparison. He could look directly behind without turning his head, scan above with minimal movement, and maintain complete awareness of his 6 o'clock position, the blind spot that got so many pilots killed. The canopy alone represented a significant tactical advantage. In combat, the pilot who saw his opponent first usually won the engagement. The Mustang made seeing opponents easier. The cockpit layout reflected American design philosophy. Everything was standardized, logically positioned, clearly labeled. The throttle quadrant on the left included mixture control, propeller pitch, and supercharger settings arranged in intuitive order. The instrument panel featured large, easily readable gauges with American units miles per hour for airspeed, feet for altitude, degrees Fahrenheit for temperatures. German mechanics had provided conversion charts, but Stössel planned to fly using American units to better understand how US pilots operated the aircraft. The fuel management system was more complex than any German fighter. The P-51D carried fuel in multiple locations, 2 wing tanks totaling 184 gallons, a fuselage tank behind the cockpit holding 85 gallons, and provisions for 2 external drop tanks. The fuel selector valve allowed the pilot to draw from different tanks in sequence, typically burning external tanks first, then fuselage tank, then wing tanks. This sequencing was critical. The fuselage tank, located behind the cockpit, affected the aircraft's center of gravity significantly when full. Pilots were trained to burn fuselage fuel early in the mission to restore proper weight distribution before entering combat. The armament panel revealed the Mustang's offensive capability. 6 Browning M2 50 caliber machine guns, 3 in each wing, with approximately 400 rounds per gun for the inboard weapons and 270 rounds per gun for the outboard guns. Total ammunition load was approximately 1,840 rounds. At the gun's combined rate of fire, approximately 600 rounds per minute, this provided roughly 3 minutes of firing time if the pilot held the trigger continuously. In practice, combat firing occurred in short bursts of 1 or 2 seconds, so the ammunition typically lasted for 15 to 20 separate attacks. The 50 caliber Browning was less destructive per round than the 20mm cannons German fighters carried, but the Mustang's greater ammunition capacity and higher rate of fire created a dense cone of bullets that made precise aiming less critical. German pilots needed to hit their targets with a handful of cannon shells. American pilots could afford to throw hundreds of machine gun rounds at an opponent, compensating for less precision with overwhelming volume. Stössel's first flight in the captured P-51D was scheduled for April 28th, with perfect weather forecast, clear skies, light, winds, excellent visibility. The test plan called for a local familiarization flight lasting approximately 90 minutes, flying around the Rechlin area to assess basic handling characteristics before attempting the longer-range evaluation missions. Oberst Peterson and a team of technical observers would monitor from the ground and debrief Stössel immediately after landing to capture his impressions while fresh. The Packard Merlin started smoothly, settling into the characteristic rumble of a liquid-cooled V12 engine. Stössel completed the pre-flight checks methodically, verifying that all systems showed normal indications. Oil pressure was stable at 70 pounds per square inch. Coolant temperature was rising toward operating range. Hydraulic pressure was normal. The generators were charging. Everything functioned exactly as the captured American pilot's manual described. Taxiing revealed the Mustang's excellent ground handling. The tail wheel was steerable through rudder pedals, providing precise control during turns. Forward visibility was good despite the long nose, better than a Bf-109, though not quite as good as an FW-190 with its radial engine. Stössel lined up on Rechlin's main runway, ran through the final checks, and advanced the throttle smoothly to take off power. The Mustang accelerated rapidly, much lighter than the P-47 Thunderbolts that Luftwaffe pilots had evaluated previously. At approximately 100 miles per hour, Stössel eased back on the stick, and the P-51D lifted cleanly into the morning air. The climb rate was impressive, over 3,000 feet per minute at this lightweight with only internal fuel. He raised the landing gear and felt the aircraft accelerate as drag decreased. The Mustang wanted to fly, eager and responsive in a way that surprised him. At 5,000 feet, Stössel leveled off and began exploring the aircraft's handling characteristics. The controls were light, and harmonious aileron, elevator, and rudder forces all balanced so that maneuvering felt natural and intuitive. The Mustang rolled quickly in response to aileron input, much faster than a Bf-109. It pitched smoothly through loops and chandelles without any tendency to tighten or fall through. The rudder provided crisp directional control without excessive force required. He tried a few stalls to understand the aircraft's behavior at minimum speed. The P-51D gave ample warning before stalling, with gentle buffeting transmitted through the stick and pedals. When it finally stalled, one wing dropped slightly, but recovery was immediate, with forward stick pressure. There were no vicious characteristics, no tendency to snap into a spin. This was a forgiving aircraft that wouldn't kill inexperienced pilots through unforgiving handling. Stössel climbed to 15,000 feet and pushed the throttle forward to test high-speed performance. The Mustang accelerated smoothly past, 300 miles per hour, then 350, 400, 420. At this power setting and altitude, the airspeed indicator showed approximately 430 miles per hour faster than a Bf-109G could achieve at similar altitude and power settings. More significantly, the Mustang remained completely controllable at these speeds. The controls didn't stiffen excessively, and there was no buffeting or tendency to hunt laterally. He pulled back into a climbing turn, converting speed into altitude in a smooth zoom climb that took him up to 20,000 feet with almost no additional throttle input. This was the Mustang's signature tactical advantage, the ability to convert speed into altitude instantly, then dive to regain speed, repeating the cycle while enemy fighters struggled to match the energy management. A German pilot in a Bf-109 might win the initial turning engagement, but if the Mustang pilot simply extended away in a shallow dive, the German couldn't catch him, and if the Bf-109 pilot tried to follow in the dive, the Mustang could zoom climb away using its superior power-to-weight ratio at altitude. After 90 minutes of exploratory flying, Stössel returned to Rechlin and landed smoothly, touching down at approximately 100 miles per hour and rolling out with plenty of runway remaining. The debrief lasted over 2 hours, as he described every aspect of the aircraft's handling, performance, and systems operation. Peterson took extensive notes, occasionally asking for clarification on specific points. The preliminary assessment was unanimous. The P-51D was an exceptionally capable fighter aircraft with handling characteristics superior to current German fighters in most flight regimes. But the question everyone wanted answered, the question that mattered strategically, was whether it could actually fly from England to Berlin and back with combat reserves. That would require a very different kind of test flight. May 2nd, 1944. The long-range evaluation flight was scheduled for 0700 hours, timed to simulate an actual 8th Air Force bomber escort mission profile. Luftwaffe ground crews had fabricated 2 replica drop tanks based on captured examples, using aluminum instead of paper, since German facilities lacked the specialized resin-impregnated paper production capability. Each aluminum tank held 108 gallons, identical to the American originals. The tanks were painted silver to match U.S. specifications and mounted on the P-51D's underwing hardpoints using captured mounting hardware. Stössel arrived at the aircraft as dawn broke across the Mecklenburg countryside. The Mustang sat fueled and ready, its internal tanks topped off with 269 gallons, and both drop tanks filled to capacity. Total fuel load was 485 gallons, enough, theoretically, for over 6 hours of flight time. The test plan called for flying a simulated mission profile from Rechlin westward toward the area where English air bases were located, then returning while documenting fuel consumption, cruise speeds, and endurance at various power settings. German meteorologists had provided weather forecasts showing clear conditions across northern Germany with light winds aloft. Navigation would follow visual landmarks and dead reckoning, no radio navigation aids to avoid alerting Allied intelligence that the Luftwaffe was conducting tests with a captured Mustang. Stössel carried detailed maps, a stopwatch, and a notebook strapped to his thigh for recording data during flight. The pre-flight inspection revealed just how much additional fuel the drop tanks represented. Each tank added roughly 100 pounds of weight when filled, plus the tank's own weight of approximately 80 pounds empty. The Mustang sat noticeably lower on its landing gear with the tanks attached, and Stössel could see the wings flexing slightly under the additional load. American pilots dealt with this weight penalty on nearly every mission, accepting reduced acceleration and climb rate in exchange for the range to reach distant targets. Engine start and taxi were routine, though the added weight made the aircraft feel more sluggish during ground operations. Stössel lined up on the runway, advanced the throttle to takeoff power, and began the roll. The Mustang accelerated more slowly than during his previous flight without external stores. At approximately 110 miles per hour, 10 miles per hour faster than his earlier takeoff, he rotated and lifted off, climbing away from Rechlin at a more modest rate of approximately 2,000 feet per minute. The drop tanks created noticeable drag. Even at cruise power settings, the Mustang flew approximately 15 miles per hour slower than it had without external stores. The handling felt heavier, less responsive though, still quite acceptable by fighter standards. Stössel leveled off at 20,000 feet and established a cruise speed of approximately 280 miles per hour, adjusting the propeller pitch and mixture settings to optimize fuel consumption, according to the American pilot's manual captured with the aircraft. The fuel flow gauge showed approximately 65 gallons per hour total consumption, at these settings slightly better than the 70 gallons per hour that German intelligence estimates had predicted. Stössel made careful notes of the time, fuel state, and power settings. If he could maintain this consumption rate, the 485 gallons would last approximately 7.5 hours. But that assumed constant cruise power with no maneuvering, no altitude changes, and no combat operations. Real-world missions consumed fuel faster. After 30 minutes of flight, Stössel reached the predetermined western checkpoint, approximately 140 miles from Rechlin. This would represent the approximate distance from English airbases to the German border. He checked his fuel state. The drop tanks showed approximately half empty, having provided fuel for the high-consumption takeoff and climb phases. The internal fuselage and wing tanks remained full. This was standard procedure according to captured American tactical documents. Burn external fuel first, then jettison the empty tanks before entering the combat zone to reduce drag and improve maneuverability. Stössel continued westward for another 30 minutes, deeper into what would be German-controlled airspace if this were an actual Allied mission. The fuel gauges showed the left drop tank nearly empty and the right tank with approximately 20 gallons remaining. He switched fuel flow to draw from both drop tanks simultaneously, balancing the consumption to avoid asymmetric loading that might affect handling. Within 10 minutes, both external tanks showed empty. The moment arrived to jettison the tanks. Stössel flipped the tank release switches and felt two distinct thumps as the pylons released. The drop tanks fell away cleanly, tumbling behind and below the aircraft. Immediately, the Mustang's performance transformed. Freed from the drag of the external stores, the aircraft accelerated noticeably, even at constant power. The controls lightened. The handling became crisp and responsive again. Stössel understood instantly why American pilots jettisoned tanks before engaging German fighters. The performance penalty for carrying empty tanks through combat would be unacceptable. He glanced at his fuel gauges. 269 gallons remained in internal tanks exactly as predicted. He'd flown for approximately 90 minutes and covered roughly 210 miles. If he turned back now and returned to Rechlin directly, he'd land with substantial fuel reserves. But the test plan called for simulating combat operations before returning. Actual bomber escort missions involved far more than simply flying to a target and back. Stössel climbed to 25,000 feet and began a series of high-speed maneuvers designed to simulate air combat. He rolled into steep turns, pulling 4 and 5 G-forces that pressed him into the seat. He executed chandelles climbing turns that bled off speed while gaining altitude. He practiced high-speed dives followed by zoom climbs, the classic boom and zoom tactics that characterized American fighter doctrine. Each maneuver consumed fuel faster than straight and level cruise, and Stössel carefully noted the time spent maneuvering and the corresponding fuel state changes. After 15 minutes of simulated combat, a duration roughly matching typical fighter engagements reported by Luftwaffe pilots over Germany, he checked his fuel again. Approximately 30 gallons had been consumed, reducing his total to around 240 gallons. The fuel flow during maneuvering had peaked at over 100 gallons per hour during hard turns and climbs, nearly double the cruise consumption rate. This explained why German intelligence officers had struggled to reconcile the Mustang's theoretical range with observed combat operations. The calculations based purely on cruise consumption were meaningless. Real missions involved high consumption phases that dramatically reduced range. Stössel turned back toward Rechlin, now approximately 250 miles distant. He descended to 15,000 feet and established an economy cruise configuration, reducing power to approximately 60% and leaning the fuel mixture. The fuel flow dropped to approximately 55 gallons per hour, the most efficient setting for maximum range. At this consumption rate and his current ground speed of approximately 260 miles per hour, he had enough fuel for over 4 hours of flight, covering more than 1,000 miles. The return to Rechlin would take less than 90 minutes and consume approximately 85 gallons, leaving him with over 150 gallons in reserve at landing. The implications crystallized as he flew eastward through the clear morning sky. An American P-51 pilot departing England with full internal fuel and 2 drop tanks could fly to Berlin approximately 560 miles jettisoned tanks, engage in combat for 15 to 20 minutes, and return home with sufficient reserves for landing. The fuel management wasn't just adequate, it was comfortable. Pilots would land with enough fuel that mechanical issues or weather diversions wouldn't force emergency landings or bailouts. More troubling still, the fuel reserves meant P-51 pilots could afford to chase fleeing German fighters far from bomber formations. Luftwaffe tactics had evolved around the assumption that Allied escorts would break off pursuit relatively quickly to conserve fuel and return to bomber protection duties. But Mustang pilots with 100 gallons in reserve could pursue targets for 30 or 40 miles, ensuring kills rather than simply driving German fighters away temporarily. Stössel landed back at Rechlin after 3 hours and 45 minutes of flight. The fuel gauges showed 160 gallons remaining, more than enough for another 90 minutes of flying. The mathematics were indisputable. The P-51D with drop tanks possessed an operational radius exceeding 650 miles, while retaining combat capability throughout the mission profile. No target in Germany lay beyond reach of American fighter escorts. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The debriefing following Stössel's long-range test flight lasted most of the afternoon. Oberst Peterson assembled a team that included fighter tactics specialists, fuel systems engineers, and intelligence officers who'd been studying American bomber escort patterns. Stössel's flight logs, fuel consumption data, and tactical observations were analyzed in exhaustive detail. The conclusions were documented in a report that would be distributed to Luftflotte Reich headquarters, the Reichsluftfahrtministerium, the Air Ministry, and fighter wing commanders across the Western Front. The report's key findings were stark. First, the P-51D could easily escort bombers throughout missions to any target in Germany with substantial combat reserves. Second, the aircraft's performance characteristics, speed, climb rate, and maneuverability remained superior to German fighters, even during extended range operations. Third, the fuel management system allowed American pilots to optimize consumption based on mission phase, burning external fuel during transit and reserving internal fuel for combat and return legs. Fourth, and perhaps most strategically significant, the drop tank system required no sophisticated technology or strategic materials. The Americans had solved the range problem with tanks made from paper and wood resins, materials Germany possessed in abundance, but had never thought to employ for this purpose. Peterson's report included a section analysing German options for countering the P-51's capabilities. The tactical recommendations were limited and sobering. German fighters should avoid prolonged engagements with Mustangs whenever possible, focusing instead on rapid attacks against bomber formations before escorts could react. Fighters should attack from high altitude when possible, diving through escort screens to strike bombers and then extending away at high speed before Mustangs could pursue effectively. Units should concentrate forces to achieve local numerical superiority, overwhelming sections of the escort screen rather than engaging across the entire bomber formation. But every recommendation came with caveats and limitations. Avoiding engagements with escorts meant accepting that bombers would receive less opposition. Attacking from high altitude required fuel and time to climb, both increasingly scarce as Luftwaffe operational tempo strained logistics. Concentrating forces required coordination and communication that Allied jamming often disrupted. The tactics were sound in theory but difficult to execute consistently against an enemy that possessed both numerical and qualitative advantages. The report also addressed the strategic implications that no tactical adjustments could overcome. The 8th Air Force operated approximately 1,000 heavy bombers by May of 1944, protected by roughly 500 fighter escorts on typical maximum effort missions. The Luftwaffe could scramble perhaps 300 to 400 fighters to oppose these raids when fuel availability permitted. But German fighters faced approximately a 2-to-1 disadvantage in numbers, while also fighting aircraft that were individually superior in most performance categories. The mathematics of attrition warfare were unsustainable. In January of 1944, before P-51 seconds became the primary escort fighter, the Luftwaffe lost approximately 90 fighters per month, while claiming roughly 150 Allied aircraft destroyed. By May of 1944, German losses had climbed to over 300 fighters monthly, while Allied losses had decreased to approximately 200 aircraft, and many of those were bombers rather than fighters. The loss ratio had inverted. The Luftwaffe was losing more aircraft while inflicting fewer losses on the enemy. Pilot attrition compounded the aircraft losses. An experienced German fighter pilot represented an irreplaceable asset, hundreds of hours of training, months of combat experience, tactical knowledge gained through survival. When experienced pilots were killed, they were replaced with graduates from training schools who might have 150 hours total, flight time and perhaps 30 hours in type. American replacement pilots arrived at operational units with over 300 hours of training, including extensive gunnery practice and formation flying. The experience gap meant that even when German and American fighters were evenly matched numerically, the Americans held a qualitative advantage in pilot skill on average. The fuel situation created additional constraints that weren't immediately apparent from combat statistics. Germany's synthetic fuel production, never sufficient to meet all military needs, was coming under increasing attack from Allied bombers. Fuel supplies to fighter units were being reduced gradually but consistently. By mid-1944, some fighter wings received barely enough fuel for essential defensive operations, with no reserves for training flights or non-critical missions. Pilot proficiency degraded when flying hours decreased, creating a vicious cycle where less fuel meant less training, which meant lower survival rates, which meant more replacement pilots who needed training but couldn't get sufficient fuel allocation. The captured Mustang represented a problem that couldn't be solved through German technical innovation or tactical brilliance. The Americans had achieved air superiority through industrial capacity, the ability to produce aircraft, train pilots, and manufacture fuel in quantities that Germany simply couldn't match. The P-51's extended range wasn't a revolutionary technology, it was a straightforward engineering solution. Carry more fuel using expendable external tanks manufactured from non-strategic materials. The innovation lay not in sophisticated design, but in recognizing that industrial capacity made such solutions practical. Peterson's report included a section on German options for developing comparable capabilities. Could the Luftwaffe produce similar extended-range fighters? The technical answer was yes. German aircraft designers could easily develop drop tank systems for the Bf-109 or FW-190. The Ta-152, a high-altitude fighter variant under development, was already planned with provisions for external fuel tanks. But the practical answer was more complicated. Germany's aluminum production, stressed by competing demands from aircraft, vehicles, and other military applications, couldn't support large-scale drop tank manufacturing without reducing production elsewhere. Using alternative materials like paper required resin production capacity that was fully committed to other military requirements, including synthetic rubber and explosives. Even if drop tanks could be manufactured in quantity, the strategic situation remained unchanged. Extending range only mattered if there was sufficient fuel to conduct the missions, enough pilots to fly them, and viable targets that required long-range operations. By May of 1944, the Luftwaffe's strategic situation was defensive by necessity. German fighters operated from bases inside Germany or occupied territories, defending against Allied bomber raids. Extended range provided no tactical advantage when the enemy was coming to you. The missions that required long-range fighters escorting German bombers deep into Allied territory, conducting sweeps over enemy bases, supporting ground forces hundreds of miles from friendly air bases were no longer feasible, given the Luftwaffe's numerical disadvantage and fuel constraints. The most psychologically damaging aspect of Peterson's report was its final section, titled Strategic Assessment and Long-Term Implications. The language was clinical and professionally detached, but the conclusions were devastating. The appearance of long-range escort fighters over Germany represented a qualitative shift in the air war that tactical adjustments could not counter. The 8th Air Force now possessed the capability to attack any target in German-controlled territory with heavy bomber forces protected throughout their mission profile. German industrial facilities, synthetic fuel plants, transportation networks, and military installations were all vulnerable to sustained bombing campaigns that would continue regardless of weather, season, or defensive measures. The Luftwaffe could inflict losses on Allied bomber raids. This remained possible. But the loss rates would be sustainable for the Allies, while the German loss rates were not sustainable. American industrial production could replace bomber losses faster than German fighters could inflict them. American training programs could replace pilot losses faster than German pilots could inflict them. The fuel, ammunition, and replacement aircraft needed to maintain operational tempo would continue flowing to 8th Air Force units, while German supplies would continue to diminish. The report concluded that absent some dramatic change in strategic circumstances, a political settlement, a technological breakthrough that restored German air superiority, or a collapse of Allied coalition unity, the air war over Germany would be decided by industrial capacity rather than tactical skill. And in industrial capacity, the disparity was so overwhelming that German options were limited to delaying tactics and hope for strategic developments beyond the Luftwaffe's control. Copies of Peterson's report reached Luftwaffe High Command within days. Reichsmarschall Hermann Göring, commander of the Luftwaffe, reportedly read it but took no action to distribute it more widely or modify strategic planning based on its conclusions. Whether Göring dismissed the findings as defeatist, believed the situation could still be salvaged, or simply had no viable alternatives remains unclear from available records. But the effect was that the report's insights, based on direct evaluation of captured enemy equipment under controlled conditions, had minimal impact on actual Luftwaffe operations. Fighter wing commanders on the Western Front read the tactical recommendations and attempted to implement them where possible. Units experimented with different attack methods, tried to improve coordination to achieve local superiority, and adjusted their approach to engaging P-51 escorts. But individual units making tactical adjustments couldn't compensate for the strategic disadvantages documented in Peterson's report. The Luftwaffe continued fighting with skill and determination, but they were fighting a losing battle against an enemy whose advantages were rooted in industrial and economic superiority that military tactics couldn't overcome. The captured P-51D remained at Rechlin for several more weeks, undergoing additional tests and evaluations. Other pilots flew it, documenting their impressions and comparing its characteristics to various German fighters under different conditions. The consensus among test pilots was unanimous. The Mustang was an exceptionally well-designed fighter aircraft that combined high performance with practical operational characteristics. It was fast but controllable, powerful but fuel-efficient, heavily armed but not excessively heavy, and capable of absorbing combat damage while remaining airworthy. More significantly, the Mustang represented an approach to aircraft design that prioritized operational effectiveness over maximum performance. German fighters often achieved slightly better performance in specific categories. The Bf-109 might turn more tightly at certain speeds. The FW-190 might roll faster at low altitude, but the P-51D was more effective as a complete weapon system. It could reach the battle, fight effectively when it arrived, and return home reliably. This practical effectiveness, combined with overwhelming numerical superiority, made it the decisive fighter of the air war over Europe. The summer of 1944 brought the full weight of American air power to bear on Germany's industrial infrastructure. The combination of long-range P-51 escorts and numerical superiority in both bombers and fighters created a strategic situation that Luftwaffe commanders found increasingly impossible to contest. Daily raids, when weather permitted, struck at synthetic fuel plants, aircraft factories, ball-bearing production facilities, and transportation networks with a systematic thoroughness that gradually strangled Germany's capacity to wage industrial war. Major General Adolf Galland, General der Jagdflieger, and one of Germany's most accomplished fighter aces with over 100 confirmed victories, had flown combat missions against P-51 formations during the spring of 1944 despite his administrative position. His after-action reports documented what test pilots at Rechlin had discovered under controlled conditions. The Mustang could fight anywhere over Germany with full combat capability. American pilots weren't nursing their aircraft home at the limits of fuel reserves. They were aggressive, willing to pursue German fighters far from bomber formations, confident that their fuel state allowed extended engagement. Galland's reports to Luftwaffe High Command throughout the summer of 1944 grew progressively more dire. In June, the Luftwaffe lost approximately 350-day fighters, defending the Reich, a 31% monthly attrition rate. In July, losses exceeded 350 single-engine fighters in the West alone, representing a 36% attrition rate. August saw similar catastrophic losses. At these rates, experienced pilots were being killed faster than training schools could produce replacements, even with training standards being reduced continuously to accelerate throughput. Replacement pilots arriving at operational fighter wings by mid-1944 often had as little as 150 hours total flight time, barely half the training that American replacement pilots received. Some German pilots reached operational units with as little as 30 hours in their assigned aircraft type, compared to American standards of 60 to 80 hours in type before assignment to combat squadrons. The experience differential manifested in combat effectiveness. Inexperienced German pilots made mistakes that veteran pilots avoided, took longer to acquire targets, and were far more likely to be shot down during their first combat missions. The fuel crisis compounded every other problem the Luftwaffe faced. Allied bombing of synthetic fuel plants, which began in earnest in May of 1944 as part of the oil campaign, had immediate and cascading effects on German military operations. By August, fuel production had dropped to approximately 50% of pre-campaign levels. Fighter units received progressively smaller fuel allocations, forcing difficult choices between training flights and operational missions. Many units chose operational missions by necessity, sacrificing pilot training that would have improved long-term effectiveness to meet immediate defensive requirements. The strategic bombing campaign that P-51 escorts made possible created a self-reinforcing cycle of German decline. Bombers attacked fuel production facilities, reducing fuel availability to the Luftwaffe. With less fuel, German fighters could conduct fewer training flights and fewer operational sorties. With fewer fighters opposing them, Allied bombers could attack with lower loss rates, allowing them to expand operations and strike additional targets. With more targets under attack, German industrial capacity decreased further, reducing the production of aircraft, ammunition, and spare parts needed to sustain defensive operations. Galland's September 1944 report to Reichsmarschall Göring and senior Wehrmacht leadership stated the situation with stark clarity. The Luftwaffe could not win the air war over Germany. The Reich lacked the resources, fuel, aircraft, and trained pilots necessary to contest Allied air superiority effectively. The Americans could replace losses faster than Germany could inflict them. Their industrial capacity exceeded Germany's ability to counter it through combat operations. The only viable strategy was to husband remaining resources for defense of critical targets and hope for political settlement before complete collapse. The report was received with hostility by some senior leaders who viewed such assessments as defeatist, but the facts were becoming undeniable to anyone examining operational statistics objectively. Germany was losing the air war through attrition it could not sustain against an opponent whose losses were sustainable and whose industrial base continued expanding production despite 2 years of strategic bombing. The captured P-51D at Rechlin flew occasional test missions throughout the summer, but by August it had largely served its purpose. The intelligence value had been extracted. German pilots understood the Mustang's capabilities thoroughly. Tactical recommendations had been distributed. No amount of additional testing would change the strategic reality that the aircraft represented. In late August, the decision was made to preserve the aircraft as a reference example, rather than risk losing it in further flight tests. It was moved to a hangar at Rechlin, where it joined other captured Allied aircraft in what had become an involuntary museum of enemy technological and industrial superiority. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians became familiar with the sight of silver cylinders lying in fields, forests, and occasionally in villages where they'd tumbled from altitude after being jettisoned by American fighters. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Civil defense organizations distributed instructions, explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons, and posed no danger unless they struck someone during their descent. The psychological impact on German civilian morale was documented in intelligence reports compiled by the Sicherheitsdienst, the SS intelligence service. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks by the hundreds, reinforced the message that the Allies possessed resources to waste, while Germany scraped for every litre of fuel and every kilogram of aluminum. The drop tanks became tangible evidence of the industrial disparity that propaganda could not obscure. Could Germany manufacture similar paper drop tanks? The technical answer remained yes throughout the war. German chemical industry possessed the knowledge to produce suitable phenolic resins. Paper mills could manufacture kraft, paper of sufficient strength. The manufacturing process for laminating paper layers and forming them into fuel tank shapes was not particularly sophisticated, but the practical answer remained no. Germany's chemical industry operated at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items could not be prioritized. Paper production was fully committed to military requirements for maps, documents, and packaging. Most critically, there was no operational requirement for extended-range drop tanks by late 1944. Fuel shortages were grounding large portions of the Luftwaffe. Pilot training was reduced to minimal levels due to fuel unavailability. Operational sorties were limited by fuel allocation rather than aircraft availability. Building drop tanks to extend range was meaningless when there was barely enough fuel for local defensive operations within Germany. The irony was bitter to German planners. The Americans had solved the fighter range problem with paper fuel tanks at exactly the time when German fighters were being grounded by fuel shortages. The final comprehensive analysis of the P-51 Mustang and its operational capabilities was prepared at Rechlin in January of 1945. The report synthesized all evaluations conducted since the first B-model Mustangs had appeared over Germany in late 1943. It documented every technical aspect of the aircraft's performance, the drop tank construction methods and materials, production estimates based on observed serial numbers and intelligence reports, and operational implications for the air war. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable drop tanks manufactured from non-strategic materials, has rendered the German heartland indefensible against American daylight bombing. Germany lacks the industrial capacity to match American fighter production, the fuel to sustain combat operations at the required scale, and the trained pilots to replace losses at current attrition rates. The air war over Germany has been decided by industrial capacity rather than tactical or technical factors. The report was filed in Reich Air Ministry archives in late January 1945. Whether senior leadership read it is unknown. By that point, technical reports analyzing American capabilities were simply confirming what battlefield reality had already demonstrated. Soviet forces were approaching Berlin from the east. Western Allied forces had recovered from the Ardennes offensive and were pushing toward the Rhine. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that could not change the strategic situation. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bombers, establishing complete air supremacy. The P-51 Mustangs that had been such a source of concern when they first appeared over Berlin in March of 1944 were now ubiquitous across German airspace. Each mission they flew, each drop tank they jettisoned, served as a reminder of the industrial disparity that had decided the air war long before the shooting stopped. The broader historical significance of the P-51 and its drop tank system extends beyond their tactical and operational impact. They represent a case study in how industrial capacity determines outcomes in modern warfare between industrialized nations. World War II was decided not primarily on battlefields, but in factories. The side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster than they were consumed in combat held a decisive advantage that tactical brilliance could delay but not overcome. The United States achieved industrial mobilization on a scale unprecedented in human history, peak wartime. Production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American forces, but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease. Germany, despite possessing significant industrial capacity and technical expertise, could not match Allied production. The reasons were multiple: a smaller industrial base than the combined Allied powers, strategic bombing of production facilities, loss of access to raw materials as territory was lost, diversion of resources to competing priorities, and inefficiencies in organization and planning. But most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The addition of American industrial capacity to the Allied cause in 1942 to 1943 made Axis defeat inevitable once that capacity reached full mobilization. The paper drop tanks falling across Germany symbolized this industrial reality in a form so simple and so stark that its message could not be misunderstood. The Allies possessed such overwhelming industrial capacity that they could afford to manufacture fuel tanks from paper, not because they lacked aluminum, but because using paper was more efficient and freed metals for other uses. German technical intelligence had performed its mission competently throughout the war. Facilities like Rechlin maintained detailed records of performance testing, material analysis, and tactical assessments. The reports on captured American equipment were generally accurate in technical terms. Where German analysis failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter aircraft. 10,000 P-51 Mustangs represented air superiority that no tactical skill or technical innovation could overcome. By the end of the war, North American Aviation and its subcontractors had produced over 15,000 Mustangs of all variants. Peak production reached 881 aircraft in January of 1945. At peak efficiency, a new Mustang was completed approximately every 2 hours. This production rate, sustained month after month, created numerical superiority that transformed tactical capabilities into strategic dominance. The March 1944 missions to Berlin, the first to be escorted throughout by single-engine fighters, marked a decisive turning point in the air war over Europe. From that point forward, no target in Germany lay beyond the reach of American bombers with fighter escort. The systematic bombing campaign proceeded with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became targets that could be attacked repeatedly with fighter escort throughout the mission. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51 seconds reached Berlin. The paper-drop tanks served throughout this final period of the war, with production continuing through 1945. Thousands were manufactured each month by multiple contractors in both Britain and the United States. The efficiency of paper tank production freed aluminum and steel for other uses while providing the range extension necessary for strategic operations. The war ended in May of 1945. The systematic bombing campaign, enabled by long-range fighter escorts, had contributed significantly to Germany's defeat. Industrial production had been disrupted, transportation networks were devastated, fuel supplies were exhausted, and the Luftwaffe was reduced to a token force. These outcomes resulted from many factors operating over several years, but the ability to escort bombers throughout their missions over Germany, made possible by fighters like the P-51 carrying drop tanks, including those made from paper, was among the decisive elements. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.